Welcome to this introductory video where we'll give you a first look at TICRA Tools with an overview of the user interface, the tabs, and the ribbons. We'll also present features such as the wizards to get easily started, as well as tutorial projects. This is the opening window from TICRA Tools where you have a number of features you can access. You can create a new project, you can open an existing project, which can also be selected from a list of most recent projects. We have access to tutorials and wizards, but let's first of all look at this license here. This will show you which products are enabled in your current run. And if you have floating licenses, and there are some of the products that you don't need, you may turn them off and make them available to your colleagues. Let's take a look at some of the wizards. This will help you set up commonly used geometries, reflector antennas, corrugated horns, arrays. Let's try to look at the grass pos wizard. We will make a dual reflector system, and with very few input parameters we can define a system that you can work on. For example, if I put 3 degrees in here, I have an offset system and I can generate all the objects needed to do further analysis of this. We also have access to tutorials which will help you, guide you in how TICRA Tools can be used for many different projects. Here's a list of all the existing tutorials. If you want to filter them, for example, you can write optimize, and then you reduce the list to things that are related to optimization. Let's assume that you want to look at an offset reflector with a matched feed. Then we click on this and we save the project. Before going into details with the project and the interface, let's look at the help manual. The TICRA Tools Users Manual gives you a number of explanations of how the software works, a software overview, the user interface, and many more things. And basically every component you have in TICRA Tools can be found in the manual. If we scroll down a little bit, you will see the tutorial examples. And here you can find the tutorial that we just opened, an offset reflector with a matched feed, where you can read a lot of details about the current project. The interface shows an object hierarchy to the left, which shows in a hierarchical manner the objects that are needed to define the geometry that we're looking at to the right. If we want to take a further look at the reflector, we can click on it and you see the reflector coming up here, and you can see the input that defines this reflector. You can unfold the entire hierarchy and go through and see all the different components. You also have coordinate system in a separate window here where you can change the coordinate system as needed. Also to the left here, you have a window with variables. TICRA Tools make it possible to use variables, which you can define and give them a value. You can even work with mathematical expressions for these variables. And they are essential when it comes to optimization, because then, of course, you use the variables to optimize. The 3D view can be modified to fit your needs. We have 3D view settings up here. For example, if I select the reflectors, we can change, just an example, the color of the reflector, as we see here. We can also create new objects showing rays, for example, rays coming from the feed coordinate system. over a certain angular region, minus 25 to plus 25 degrees in phi equals 0, and of a certain length, 3 meters. And then we see how the rays emanating from the feet coordinate system and are being reflected in the reflector. Other plots are available. If we select the feet, for example, radiating feet without mode converter, we can look at it here, and we may just see the geometry of the corrugated horn here. We can also see the feet as a 3D component, as we see here. Another way of looking at all the objects is to look at the Object Explorer, which is divided into various groups, or you can unfold them all and simply browse through here and find the object you want to look further at and do modifications for. You may use the editor that I show here, or you may right-click and select Edit with Dialog. This gives you a different access to editing the parameters, and sometimes this can be more convenient, and you can have many of these editing windows open at the same time. Here you can also access the manual with help, which will take you directly to this particular component, in this case the radiating device. If you need to create other objects, you have the ribbon available here, where, for example, you can generate a new reflector by simply clicking here, saying OK, and you get the possibility of defining a new reflector to add to your geometry. There are waveguides, for example. You can make combined devices of various kind. Geometry definitions, a new rim, elliptical rim, for example, where you define the size of a new rim. Frequencies, coordinate systems, field storage. If you want to do a grid analysis over a spherical grid, for example, you can define the extent of your grid and the sampling of your grid here. To the left of the window, you have, in addition to the Objects tab, you have the Optimize tab, which is where you define an optimization manager that helps you do various optimizations. You have an uncertainty quantification manager where you can do uncertainty quantifications. And then you have the Command tab, which is where you define the commands to be executed in your job. When you run a job, it's the main function that we see here that is being executed. And you can define additional functions to do various kind of things, get optimum, for example, get field. And any of these functions can be called from the main function. As we see in this particular example, we call the function which is convergence check. This is a very useful feature to define many different functions that you can call from the main function. When you see that the main function contains calls to function, as seen here, for example, or some up here, which are disabled, this one is enabled, you can see the details of that particular function by right-clicking on whichever you want and say go to function. Then this window opens up and you can see the details of that particular function. Once you run a job, they will show in the Jobs tabs. While they're being executed, you can see the progress, and of course you can later on browse through this progress and see what happened. And finally, there's the Results tab, where you can browse through all the jobs that have been executed. If you select one of them, you can read comments about them down here. And you can also, if you double-click a particular job, you will see different output from that particular job. In this case, we have computed some spherical cuts at 3 different frequencies and 3 different phi values. And we can also see that some optimization has been done. So for example, we can double click optimization variables and we can see which variables are contained in that particular optimization, what the original value was, and what the final value is. And if you want to continue with those values, you can load final values, but you can also load the original values. You can plot many of the output data. Let's assume we want to see the pattern at 14.25 gigahertz, 45 degrees. I double click this to get this pattern. We can then take another job. And let's assume that we want to compare the patterns from this run with the one we just did here. Then we can double click on the spherical cut and we can select the frequency and the phi angle, and we can choose to plot this on the same plot we just did. And we now see the two patterns on top of one another. If we want to see more details about some of these plots, we can select one of them by left clicking, selecting it, and then right click to see options. For example, we can insert a beamwidth marker, the 3dB beamwidth, and it will show up like this. We can also choose by right clicking on the canvas to select, for example, all curve global maxima. As you can see, the peak is a little bit difficult to spot because there are two almost identical curves on top of one another. Then we can right click and manage the curve markers and select one that we delete, and then we can just see the other one as shown here. Thank you for watching. We hope it has given you a first insight into what TICRA Tools is all about. Do not hesitate to contact us at info@ticra.com, and remember to follow us at LinkedIn.